I'm going to be talking about cross-platform database support on Overdrive. I'm Sean Walker. I guess my claim to fame is that I was the creator of .NET Nuke many years ago, back in, I think, 2002, 2003. I'm a former Microsoft MVP from 2004 to 2016. I'm an ASP insider, recent creator of a new open source project called Octane, and I'm also a member of the .NET Foundation Project Committee. And professionally, I am CTO of the professional services organization within Cognizant. I wanted to point out that it was a real honor last year to be selected as one of the speakers for .NET Conf as part of the .NET 5 launch. And I did a presentation there, Trailblazer, building dynamic applications with Blazor. And I was quite surprised at the reach of that presentation. So this is through the YouTube link, but 14,500 views and 300 people said they liked it. So that was good. That just kind of proves that how much impact .NET Conf has on the .NET community in terms of providing great content. I definitely want to give some cred to Charles Nurse, a longtime colleague of mine, former chief architect of DNN Corp, also a former Microsoft MVP. And he's recently retired, and he still contributes to open source. And so it's important for me to call out that a lot of the implementation of the concepts I'm going to be talking about today in this presentation were actually built out by Charles as part of his open source contribution to Octane. So thanks, Charles. Definitely appreciate your hard work. So getting into talking about multiple databases. So the term database agnostic is sometimes used as a term for describing software that is heterogeneous, meaning it can support database management systems from multiple vendors. And so what's the benefit of database agnosticism? Well, it allows you to be cross-platform, especially on a platform like .NET Core, which is cross-platform. It's really important to be able to support databases as well that are cross-platform. And even outside of the cross-platform goals that your software might have, there's sometimes the goals within a single organization that they might have multiple environments. Well, often they have multiple environments that they need to support, such as dev, QA, stage, production. And you might not want to be using the same exact database in all of those environments, sometimes for licensing reasons, for like license cost, resource allocation, and other things. You might want to have your developers use a different database than what you're ultimately going to use in production. Also talking more or thinking more about databases in general, in 2021, GitHub did a developer survey, and one of the questions they asked was around database usage. And so the breakdown of the most popular databases was quite interesting. So looking at databases in general, you'll see that MySQL, PostgreSQL, SQLite, and SQL Server accounted for a significant portion of the database usage today. And so obviously, if you're creating software and you can provide support for all of those databases, you're going to reach a much larger potential market. And this is important, I guess, for the software that I'm going to be talking about today, in that the framework that I had developed in an open source manner was built on .NET Core, but initially it only supported SQL Server. And so that was quite restrictive in terms of the number of developers that could actually use that software. By adding multiple database support to it, it opens up a whole new area and a whole new possibility for usage in many more environments. And I also thought that it was interesting with all of the talk about NoSQL databases in the last decade. Relational databases are still very popular. Like based on the GitHub developer survey, relational databases still accounted for 65% of the overall usage, which is quite significant. If we then shift gears to talk a little bit about architecture. So if you're going to build an application that supports multiple databases, the way you have to do it is by creating a generic abstraction layer that allows your software to interact with the underlying databases without knowing anything about them. And the abstraction layer needs to have two key capabilities. One is it obviously has to be able to do data access for the most common operations like create, read, update, and delete. But you also have to be able to do provisioning, So you have to have some capability to set up that database, like provision the schema, creating tables, indexes, foreign keys, and also facilitating upgrades of the database as your software transitions from one version to the next. EF Core has a lot of great capabilities. So EF Core was developed with cross-platform goals in mind because obviously it needs to satisfy the cross-platform goals of .NET Core itself. EF Core does make it straightforward to develop applications that support a single database management system. So if you're going to build software that supports just SQL Server, that's pretty easy to do. Or if you're just supporting SQLite, pretty easy to do. However, if you're creating software that needs to support multiple databases, it does get a bit more complex. And the good thing about EF Core is that the designers of EF Core created the framework with a lot of extensibility in mind. So you can adapt it to additional scenarios that are sort of outside the normal operating scenarios, and this allows you to support multiple databases. So most of us are familiar with EF Core, but just as a refresher, of course, it has the two sides that it provides capabilities for. It has a lightweight ORM, which allows you to do data access. All that data access is performed by using a model that you define, and then a context object, which allows you to interact with the underlying database for querying and saving the data. It also has capabilities called migrations, and migrations are the way that you would do basically the provisioning of schema in your database. So the initial setup. Migration classes are created as code files, so actual code, C# code that you would build just like you would write your normal application. And migrations are executed against the database to provide that capability for doing provisioning and upgrading. So the application that I'm going to be talking about today is a modular application framework that's open source, that's created for the Blazor platform called Octane. Octane has some interesting capabilities that are provided for you out of the box. Things like multi-tenancy, a composable UI framework, a modular architecture. It's got a granular permission model that you can take advantage of, customizable themes, an admin user interface for interacting with the software, and of course a headless API and the support for multiple databases, which is really what we're going to concentrate on today. So Octane, like I said, was originally created and supported only a single database, which was Microsoft SQL Server. But in the past year, it was enhanced to support PostgreSQL, MySQL, and SQLite. And there's the ability to add additional database providers as well, for those use cases for people needing other databases as well. So the Octane database requirements were fairly specific. Just like any application has its specific needs, Octane as a framework had its own needs. One of the core features in Octane is multi-tenancy. So, and not just shared tenancy, but isolated as well. So you can run the application and you can separate sort of workloads by tenant, and the underlying data can be stored together in the same database in a shared model, or it can be isolated in separate databases. So in order to support multiple databases, it needed to support multi-tenancy. The framework is also modular, so it's very extensible and allows you to build modules that can plug in at runtime to provide additional functionality. Of course, those modules that plug in also need to be able to take advantage of the multiple database support. So there needed to be, key features built into the framework so that software developers could build modules that would interact with multiple databases. The runtime deployment capability is also really important. So Octane has always had this notion where you should be able to very easily install additional functionality without being a software developer. And so if you're without any technical knowledge and you're an end user, you should be able to add additional functionality to your application. And so we'll talk a little bit more about that, but the runtime deployment capability was essential to meet the needs for the Octane framework, and it needed to be optimized. So one of the key philosophies behind Octane is it needs to be very high performance, and it's built on .NET Core. So obviously it received all the benefits that .NET Core can provide in the performance area, One of the ways that .NET Core provides superior performance to perhaps some of the more legacy frameworks from Microsoft is it uses an opt-in approach. So it doesn't require you to install a bunch of things that you're never going to use within your application. You typically would only install those dependencies that you actually need. And so in the case of database providers, we didn't want to force people to actually install support for multiple databases if in fact they were only going to use one database. So that was a key aspect of this as well. So talking a little bit more, I guess, about the technical implementation of multiple databases within Octane. So from a high level, we had to break it down, the architecture, into a couple of different workloads. On the client side, we needed the ability for end users to be able to configure their specific database. So we needed some kind of a user interface capability so that they could select the various options for connecting to a database, basically building a connection string. On the server side is where the really heavy lifting happens, and that's where we have sort of the concrete implementation of our generic abstraction, which allows developers then to interact with underlying databases without necessarily knowing a lot of the intricate details of those databases. The actual data providers are declared in our app settings file. So the list of the databases that I've already described, so SQL Server, SQLite, MySQL, and PostgreSQL, are all defined in app settings. And basically, that's where it tells the framework, where to find the client components and where to find the backend classes. So on the client side, like I said, we're using Blazor in Octane. So everything is a Razor component, of course. So you define a control type, which is your user interface fragment, your Razor component. These components that are specific to database configuration have to implement a specific interface called iDatabase config control. And then as the user interacts with the application and they choose different database types, it automatically renders a different Razor component for them with different user interface options. And ultimately, what that Razor component does is it returns a connection string, which is used for connecting to that specific database. On the server side, again, we have a type, which would be used to reference a specific class, which is going to be dynamically instantiated at runtime. The database providers are derived from a base class called database base, which inherits from an interface called iDatabase. So we had to create a generic interface for this so that we have a contract that all database providers need to implement. And I guess the question that would be asked is, why did you have to create your own abstraction over something like EF Core, which already has its own abstraction? Well, it turns out that when you start implementing multiple database solutions, there are things that are very specific to each database that you need to account for. So, of course, during startup, when you would typically call things like use database, you would typically call commands like, use SQL database or use SQLite database. So you need to be able to abstract those types of operations away so that the type of the database is determined at runtime and instantiated in a more dynamic manner than a static manner that you're used to when you typically write startup logic. There are migration commands that differ as well between different database providers in EF Core. For example, things like creating an auto increment column. So an identity column in SQL Server is done differently in SQLite or some of the other relational databases. So you have to abstract things like that away so that the developer interacts with this one common interface method as opposed to calling the more specific methods that are available in each provider. Also, more primitive commands like interacting via actual raw SQL is again something that is specific to each database provider. And so we needed a higher level abstraction in order to make those types of calls. And then we also have support for the migrations history table as well, which is, of course, part of EF Core and keeps track of which migrations have already been executed on your database. We wanted to extend that migration history table with some additional properties. so that we could keep track of the specific version of the software that they were executed against, the date, timestamp of when they were executed, those are additional fields which are not provided by default as part of EF Core. And in order to keep things completely separated from one another, you can develop your database providers as NuGet packages. Of course, the NuGet package would include the Octane specific database provider, as well as any of the dependencies that it requires. So those are all packaged up into NuGet packages, and those NuGet packages are installed at runtime based on the user selection. So if a user selects that they're going to use SQLite, then it will install the SQLite database provider package. And this is how we ensure that not all of the database providers need to be installed by default. The framework also needs to provide support for some other fundamental capabilities, mostly around migrations. But so we have a base entity builder class, which makes it very simple to define a new entity, which will be provisioned in your database. And then we have a multi-database migration class as well, which extends the migration builder, which is part of EF Core, and provides some additional support for dealing with multiple databases. This is especially critical for our multi-tenancy capabilities that we have in Octane. And with that, I'm going to shift over and actually show you some code, show you a demo. So I'm running Visual Studio 2022. I have the latest version of Octane from the dev branch. Actually, it was just released today for .NET 6. So if we open the server project, and we take a look at our app settings, we're going to see that here we have our available databases that are defined. So all of the different types, which I already described. We don't have a database which has been installed yet. So our connection string here is blank. We're going to run this, and which will actually fill in this connection string for us. But before we do that, looking in the migrations folder in the server project, we can see that we have an entity builders folder, which is defining all of the various entities that are part of the Octane framework. So if we open one of these up, we'll see, it's basically has logic for defining a table, including its name, its primary keys, foreign keys, and any of the columns that it supports. Using this approach is basically using the so-called iDatabase interface. So all of these add auto increment column, add string column, these are all abstractions over top of standard EF Core, which allows us to support multiple types of databases. If we look in these other folders, we'll see that we have the migration scripts as well. So if we pick one of the more recent ones here, this is a migration script that brought the database up to the version 3.0 level. And of course, we have the standard up and down type of methods that need to be implemented, which is the exact same way that you would develop any application using EF Core migrations. So with that, we're going to run the application. And by running it, it's going to show me a installation wizard, which allows me to basically get the software installed. And so we're going to initially see how we use this user interface capability to show different Razor components. So if I choose local DB, I have a few different options here. If I choose SQL Server, I have different options as well. I think by default, I'm going to install this on SQLite because it's just very simple. So I have to provide some basic parameters for creating the initial user account. And I'm going to click install now. And this is going to run all of those migration classes, which I already just described to you or showed you in Visual Studio to create all of those entities in the database. So I have my initial site created. I have a couple of pages. If I log into this site using that user account that I had just provided the credentials for, I can see that there's some additional functionality that's revealed as well, some additional pages. I'm going to go into the control panel, and I'm going to go into the site settings. And I'm going to go down, and I'm going to show you a few things here. So the hosting model that this was installed for was Blazor Server, and we're using pre-rendering. The tenant is, the default tenant is called the master tenant. It's using a SQLite database, and here's my connection string, which was, of course, created when I installed the software itself. Of cool thing about Octane, I can switch this on the fly. I can say, hey, I actually don't want to run on Blazor Server. I want to run on Blazor WebAssembly. And I can save this, and boom, it'll refresh the site, and I'm running on Blazor WebAssembly now. So this is one of the cool things about Octane is it supports both hosting models for Blazor very fluently. All right, so now I have a site that's running SQLite and running on Blazor WebAssembly. So I'm going to show you the multi-tenancy capability of Octane now. So I'll go into my admin dashboard, go into site management, and I'm going to add another site. So in Octane, the different sort of tenants are referred to as sites. And a site can have its own unique set of users, roles, content, files, completely sort of separated from one another. So I'm going to add a site. So this site I'm going to call test. I'm going to give it a unique URL so I can browse to it called test. I'm going to give it the Blazor theme, that the standard purple theme, which is obviously different than the default Octane theme. Choose a container. I'm going to use a default site template. And actually, I'm going to install this on Blazor Server. So even though this is the same installation, and the first site is running on Blazor WebAssembly, I can run this site on Blazor Server, fully possible. So, and I'm going to say pre-rendering is enabled. And now we get down to the tenant, and this is where we're talking about the database. So I can choose to actually install this in the master tenant, which would mean I'm using one shared database for both of these sites. Or I can say, hey, I want to create a new tenant. So I'm going to do that. And this tenant, rather than installing it on SQLite, I want this tenant to be local DB. So it fills in some of the default information for me. And I'm going to have to provide the credentials that I provided for this privileged account. And so basically, if I click save here, it's going to create a new database for me on local DB, create a new site that's part of this installation, provision that site with some basic content. Of course, we're using a different theme here. We're using the standard Blazor theme, but this is all the same application. So if we go and we look in the admin dashboard here, and we look at these things, we'll see that, yeah, this is running Blazor Server, and it's running on local DB. Whereas if I go to my, my other site, the original site I created, we will see that it is running on, like I said, still running on Blazor WebAssembly and SQLite. So this framework is very powerful, right, in that it can support multiple databases for the underlying content, and it can support both hosting models for Blazor. Now, a framework like this wouldn't be that useful unless you could extend it. And so we can do that by creating modules. So if I go into the admin dashboard and I go into the module management area, I can say that I would like to create a module. Well, first of all, I'll show you this. So we can go in and we can say, I'm going to install a module. And we'll see that there's a number of different third-party modules that have been created for Octane already, and these ones are the ones that are freely available. I can download them and install them. That's not really what I want to do for this demo, but I want to create a module. So I can go into the module management area and say I want to create it. I can fill in some basic information. So the owner of this is going to be Octane. I'm going to call this presentation. I'm going to choose the default template that's provided with Octane, and it's going to reference version 3, which was just released today. And this is the location where it's going to create, basically scaffold out all of the code for this module. You say create module, it created it, tells me that the code is at this location. And of course, I have to compile it first. So I'm going to shut this down for now. Open my file manager, go to that location. Here's all the code it created for that module. I'm going to open that in Visual Studio 2022 preview. All right, so basically a module in Octane is basically a full-blown Blazor application with the client server shared projects that you would typically expect. If we go into the server project, we can look at the migrations folder. Again, it follows the same exact pattern that the Octane core framework follows. So it's actually scaffolded out an entity here called presentation. So it's going to create a database table called Octane presentation with primary key, foreign key, basically only one column in this table, or a couple of columns, module ID and name. The initialize up is going to execute that entity builder for me. So I'm going to build this. So by building this solution, it compiles all of the projects, and it also deploys the DLLs that are associated with them to my Octane framework instance. So that all compiled fine. I'll go back to my Octane instance now, and I'm going to run the application. One thing to keep in mind, though, is when I run the application, right, the framework, I created a new module. But for the framework to be aware of it, it needs to actually provision all of the database assets that are part of this module. And it needs to provision them not just on one database, but it's going to have to provision those on SQLite, because that was the original site. And it's going to have to provision it on LocalDB, because that's my second site. Octane takes care of that for you. So on startup, it recognizes that there's a new module. It executes the migration logic, and it executes it against all of the available databases that are part of the installation. So the site's going to come up here in a minute. All right, I can go to this page. I can look in my module list, and I can see that I have my presentation module, which I just created. I'm going to add that module to the page. All right, so it added it. And I'm going to say, add some content there. So this content that I just entered is being stored in the SQLite database that I had created earlier. So scaffolded out a whole module, and it works. All right, so now I'm going to go to the other site. I'm going to go to the other site I created. I'm going to go to this page. I'm going to select the module, presentation again, add it to this page. Add some content to this one. Again, it works. And so that means the migrations were successfully executed against the LocalDB database as well. So that pretty much sums up the demo, but it shows some of the power of, I guess, dotnet Core, EF Core, and of course the Octane framework. Switching back to my slides, some of the challenges that you're going to run into in developing developing applications that support multiple databases. The standard CLI tools that you are typically used to using for dealing with EF core migrations. So the ability, right, to go into your database, manipulate your database directly, and then use the CLI tools to generate the migration classes. They don't really work except for in very specific scenarios. So basically, they rely on the fact that you have static definitions defined for your application. And in a more sophisticated framework like Octane, there aren't any static references that are there. It's all dynamic, and of course it's multi-tenant. So those CLI tools aren't capable of handling it. So you have to hand create those migration classes. Of course, that's not very difficult to do once you become accustomed with what migration classes are all about. Another thing is trying to avoid the use of raw SQL is difficult. Especially because during migrations, you often have to execute maybe some updates to update data in particular tables. And so as much as you try to avoid using SQL, there always are some scenarios that are going to come up where you have to fall back to it. And each database, of course, has different SQL dialects, which does still create some challenges. Other things that were kind of a surprise, or things that we needed, that we ran into along the way. PostgreSQL uses snake casing for database objects. So snake casing, completely different kind of syntax than what other databases support. So there had to be, provisions built in to support that. PostgreSQL also supports a Boolean data type natively. So holding values like, standard true false, whereas other databases do not actually have a native Boolean type. They use things like a bit type to provide support for a Boolean. We also discovered that the EF core providers that are provided by Microsoft and third parties often provide inconsistent functionality. So there'll be methods that are implemented, but they don't always work as you would expect. And then if you're debugging migration issues, those can be challenging as well. So these are some of the challenges we ran into in supporting multiple databases. Obviously, I already mentioned Octane 3.0 was released today. It was migrated fully to .NET 6. One of the new features was that you can support multiple hosting models per site. It was upgraded to Bootstrap 5.1.3. Next step on our roadmap is Octane 3.1, and that is adding OAuth 2 and OpenID support, which we're going to take advantage of the awesome work that's been done in OpenID Dict, if that's the way you're supposed to say it. So I hope I still have some time for some questions.
We're actually right over time, Sean.
Okay.
We're
All
right
right.
a little bit over it. So great content, though. But there are some questions out on Twitter. So just go look for the hashtag .NETConf, and it should be like the last couple tweets there.
Okay.
But
all right.
Thank you so much for the session.
Thanks so much.
Thank you.
Yep.
All right.
Thank you.